Hello. This is about the calculus homework assignment from section 8.9, which is about probability. There are 12 problems to go, and I'm going to explain one at a time. Question number 1. Determine whether the following function is a probability density function. So fx is equal to a linear function 1h times x on the interval of 0 through 5. So this means when we graph it, it is a linear function which goes through the origin, which has a positive slope. And we are only looking at the x is 0 through 5. So x is 0 through 5. And other than that part, we assume everything else is 0. Okay, so everything else is 0, 0, but 0 through 5 looks like this. The function is called the probability density function if the following three things are satisfied. First of all, it must be continuous almost everywhere, with the exception of a finite number of points. In this case, function is basically 0 everywhere, and the line, it is continuous everywhere between 0 through 5, and 5 through infinity, it is 0 everywhere. So it is not continuous at one point, but everything else is continuous. So continuity is okay. Continuity is okay. Next thing to check is non-negative. So we need to make sure that this function is non-negative in the interval. And indeed, this function is always non-negative, so it's okay. Third thing is the area under the curve must be equal to 1. So we need to check the area here is equal to 1 or not. To find the area, in general, we are going to take an integration of the function. And this is equal to 1 over 16 of x squared. And you plug in 0 and 5, and that is equal to 25 over 16. This is not equal to 1, so this is not satisfied in this case. So this function is not a probability density function. By the way, when you have a linear function, the area under the curve is really a right triangle. So instead of using the integration, you can use area formula for the triangles. So in this case, base is 5, the height is 5 over 8. So the area is equal to 1/2 times base times height, which is 1/2 times 5 times 5 over 8. And that is clearly not equal to 1. So we got the same conclusion. Okay, move on to number 2. Determine whether the function fx is equal to 5 times cosine 5x, 5 times cosine 5x on the interval of 0 through pi over 10 is a probability density function or not. Things to check is the same as the problem number 1. So we have to check it's continuous almost everywhere, must be non-negative in the domain, and the area under the curve must be equal to 1. First of all, cosine function is continuous everywhere. So this is no problem. Is this a non-negative function? So cosine function is like this. So it could become negative. However, we are only looking at these intervals. So when x is between 0 through pi over 10, when x is between 0 and pi over 10, how about the range for 5x? So 5x is you multiply each side of this inequality by 5. 5x is between 5 times 0 and 5 times pi over 10. So the angle inside the cosine function is between 0 and pi over 2, which means this angle is angle between 0 and 90 degrees. So cosine must be positive. So this is always positive or 0 in this domain. So non-negativity is satisfied. Third thing to check is area. So let's find the area by integrating the whole interval 0 through pi over 10 of the function. So the integration of cosine of kx is, remember the cosine of ax plus b's integral is equal to sine of ax plus b, but you have to divide it by a. So this is going to become sine of 5x, but you're going to divide it by 5. So actually 5 is crossing out. So this is antiderivative, and you plug in these two numbers. Plug in pi over 10, you want to get pi over 2. Plug in 0, you want to get 0, sine 0. So this is equal to 1 minus 0. So the area under this curve is equal to 1. Because those three things are satisfied, this is called the probability density function. Okay, so the function is probability density function because it is non-negative over the interval and only have finitely many discontinuity over the interval. And finally, the area under the curve is equal to 1. Okay. Okay, move on to problem number 3. Verify that the function below is a probability density function for a continuous random variable x over the given interval. Determine the specified probability. So now you have, well, first part of the program is similar to the problem 1 and problem 2, but we have additional computation to do. So now we have a parabola. This is a quadratic expression, so the graph should be a parabola. This is a factored form. So looking at the interception, this is x-intercept is 0, and another intercept is 10 over 9. And since the coefficient for x squared is negative 9 over 2, so it's going to be like upside down parabola. So the graph looks like this. We are only looking at the interval of 0 through 1. 1 is here. So it is continuous everywhere. And it is non-negative. So it's clearly continuous almost everywhere. And it is non-negative in this interval. All we need to check is the area under the curve between 0 through 1 is equal to 1. So what we have to check is integral of 0 through 1 of this function is equal to 1. Since this is a very easy expression to expand and integrate, so let's expand it. So it's going to be 5x minus 9 over 2x squared dx. And after the integral, it's going to be 5 over 2x squared minus 3 over 2x cubed. Plug in 1, we're going to get 5 over 2 minus 3 over 2 minus the value when we get to 0. So 0 minus 0. So that is equal to 1. So, well, done. So area is equal to 1, non-negative, continuous. So this is probability density function. Now let's find the probability now. So second part of the problem is determine the specified probability. What is the probability that the random variable x takes a value which is less than 0.4? Area. Yeah, the probability is area. So we want to find the area under the curve for x below 0.4. So we want to find the area here. So this is integral of the same function, but only from 0 through 0.4. Since this is the same function, its antiderivative is same thing as this one. So let's copy that. So let's just copy that one. So it's going to be 5 over 2 x squared minus 3 over 2 x cubed. And the value you're going to plug in is 0.4. So plug in 0.4, it's going to be 5 over 2. Right. So it's going to be 5 over 2 times 0.16. Yeah, I'm just using a decimals, but you can use fractions if you want. 3 over 2 times 0.064. So that is equal to 0.0840 minus 0.096. That is equal to 0.304. Okay, so the area under the curve here is 0.304, and that is equal to the probability that the random variable x takes a value less than 0.4. Okay, now move on to problem number 4. Verify that the function below is a probability density function for continuous random variable x over the given interval. Determine the specified probability. So the function f of x is basically 0 for all x less than or equal to 2, and 160 over x to the power of 6 for x greater than 2. Okay, so this is a function, something similar to 1 over x, something similar to 1 over 6, 1 over x. So as the denominator is getting larger, the y value is getting closer to 0. But because it is multiplied 6 times, so if 1 over x is going like this, 1 over x squared is going like more like sharply drop down to 0. So the graph looks like this. But for only x is greater than 2. For x is less than or equal to 2, the function is basically 0. So it doesn't take any value. Okay. So clearly, this function is continuous almost everywhere. Almost everywhere. Okay. It is continuous in this interval. This is continuous here. There is discontinuity at this point, but as long as it is continuous almost everywhere, except like for a few points, then that's fine because we can integrate this function. So continuity, no problem. Non-negative part, clearly no problem because this is non-negative and this is always positive. So this is no problem. Now the hard part is you need to check the area under the curve is equal to 1. So we need to find the area here, which is integral of 160 over x to the power 6 for x greater than 2. Okay, so that's the area under the curve. And we need to show this is equal to 1. Okay. Since this is an improper integral, I'm going to use b to say b goes to infinity of 2 through b of 160 over x to 6 dx. This is same thing as 160 times x to the power of negative 6. So when you integrate the power function, you raise the power by 1, but you had to divide it by that number. Okay? So this is going to become negative 32 over x to the power of 5. And you plug in 2 and b. When you plug in b, it's going to be minus 32 over b to the power of 5. Minus, when you plug in 2, it's going to be negative 32 over 32. So this is equal to basically 1 minus, this is become 1 minus 32 over b to the power of 5. So as b goes to infinity, this fraction is getting closer to 0, so the area is equal to 1. So now we just showed this is a probability density function. Okay. Now next thing to do is just you need to find the probability that the random variable takes a value between 4 and 8. Okay. So we need to find this. This is basically we need to find the area under the curve for x between 4 and 8. Okay. So we are going to integrate this one. Now, again, we already know what its antiderivative is. So we just borrow that result. So negative 32 over x to the power of fifth, and you plug in 8 and 4. Eight is equal to 2 to the power of 3. So it's going to be 2 to the power of 15 here. Minus, or it's going to become plus 32 over 4 to the power of 5. And what is 4 to the power of 5? It is same thing as 2 to the power of 10. Now, this is minus 2 to the power of 5 over 2 to the power of 15. And this is 2 to the power of 5 over 2 to the power of 10. So it's going to be 1 over 32 minus 1 over 1032. Yeah, 2 to the power of 5 is 32, and 2 to the power of 10 is 1030. 1032. No, 1024. Okay. We need to answer this one in decimals. So we really need a calculator, but well, this is basically the answer. So when you rewrite this one, it's going to be 1024 of 32 minus 1. So the final answer in exact form is 31 over 1024. Okay, next problem. Find the value of C so that the function below is a probability density function for a random variable over the specified interval. So now we have a slightly different program. So this must be a probability density function on interval of 0 through c. This is an exponential function, and it is a continuous function. So it is continuous function for whatever the value c is. Exponential function is always positive. This is always positive, so non-negative part is clearly done. So all you need to check is to make the area equal to 1. So this is an exponential function with a negative exponent here. So the graph looks like this. Okay. And we want to find the value c so that the area here become 1. So here is how to set up the equation. So the integral of 0 through c of the function must be equal to 1. Let's integrate this. Integrating this one, we will get negative 4 e to the negative 2x. This is an exponential function, so the integral is like this. And you plug in 0 and c. Okay? Okay, plug in c, you're gonna get negative 4 e to the negative 2c minus you plug in 0, so e to the power of 0 is become 1. So it's going to be minus minus 4, which is plus 4. Okay. This is an equation in terms of c. We need to solve this one for c. Okay. So to solve for c, first of all, combine like terms. So 3 is equal to 4 times e to the power of negative 2c. Next, divide both sides by 4 to make like this. And this is an exponential equation. So let's use a log to rewrite this expression in terms of log. So this is same thing as ln of 3 over 4 is equal to negative 2c. Okay, remember ln is log of base e, and of a is equal to b indicates a is equal to e to the power of b. Yeah, this is just a rewriting. Okay, now divide both sides by negative 2. So it's going to be negative 1 over 2 ln 3 over 4. Okay, so that's going to be the value of c we wanted to find. Okay, let's move on to next problem. Okay, now let's move on to the problem number 6. Compute the mean and the median for a random variable with probability density function shown below. So we have a probability density function. It's a linear function like this on x between 0 through 22. Okay, so here's how to find the mean. To find the mean, or in other words, the expected value of x, is defined to be the integral for all domain of the product of the function times x. Okay, so probability density function multiplied by x, no matter what this is, multiplied by x and take an integral. Okay, so we're gonna use this one to find the mean. So mean is, in this case, we really do not need to integrate negative infinity to infinity because the function exists only between 0 through 22. And this is just a line, okay? And we just need to find the integral for 0 through 22 of the function f multiplied by x. So it's gonna be this, okay? Multiplied by x, that's how we find the mean. So now integrate this one. Forget about this number, it's just a constant multiple. Integrating x squared using a power rule, you're gonna get 1/3 x cubed. And you plug in 22 and 0. So this is gonna become 242, 3, and 22 cube. Let's simplify this. 22 cube is same thing as 11 times 11 times 11, 2 times 2 times 2. 242 is decomposed into 2 times 121, which is 11 squared. Okay, so that's how we factor it and reduce the fraction. So this is gone and this become 11, and this is gone, this become 4. So the answer is 11 times 4 over 3, which is about 14.666, 14.67. So average is somewhere here. Yeah, somewhere a little bit slightly right of the midpoint here, okay? So that's mean. Now, next, we need to find the median. What is a median? Median is a place that cuts the region into two regions whose area are both 0.5. So you need to find the vertical line, the position of the vertical line that separate the area under the curve into two equal area. Okay, so that's the median. So in this case, since this is a right triangle, like this, we can use some kind of property of a similar triangles to find the right place to cut this one into 50-50. But it doesn't work when we are working non-linear functions. So I'm going to show how to do this in general. So we need to find the place m. So the integration from negative infinity to m, integration of the left side, negative infinity to m, of the probability density function should be equal to 50%. Okay. So median is the value m such that the integral become 1/2. Okay. So this is the median. So let's find the median in this program. So in this case, we don't need to start from negative infinity. We start from 0. So 0 through somewhere, 0 through somewhere. Okay. 0 through somewhere to make this area equal to 1/2. Okay, so the function we have is this. So we just need to take this integral. Let's multiply both sides of the equation by 242. So it's gonna be like this. So this is equal to 1/2 x squared after taking the integral. And you plug in 0 through m, and that is equal to 121. So 121 is equal to 1/2 times m squared. multiply both sides by 2, it's going to be 2 times 121 is equal to m squared. But since clearly m is positive, m must be positive in this case, because m must be somewhere between 0 and 22. So m is positive square root of 2 times 121, which is equal to 11 square root of 2. So that's the median. It's like about 15.4. So it is not equal to the mean, but somewhere close in this case, somewhat close. Okay, basically the same problem, but with different function. So now we are working with nonlinear function. So again, the problem is find the mean and median. So let's find the mean for problem number 7. So mean is equal to the integral of x times fx for negative infinity through positive infinity. But since fx is only defined for 0 through 21, we can make it to 0 through 21. Everywhere else is 0. So it's going to be 1 over 3087 times x squared times x. So it's going to be x cubed here. Okay. Integrating this, the number is irrelevant. So power rule, x to the power of 4 divided by 4. And you're going to plug in 0 through 21. Now, this one is a multiple of 9. So I'm going to decompose it into 9 and something else. It's going to be 9 times 343 times 1 over 4 times 21 to the power of 4th. Now let's simplify this. Denominator is 9 times 4 times 343 is, guess what? It's 7 cubed. Okay, now 21 to the 4th is same thing as 3 times 7 4 times. So it's going to be 3 to the power of 4th and 7 to the power of 4th. So reduce this part, we want to get 7. And reduce this part, you want to get 9. So the answer is 63 over 4, which is same thing as 15.75. Now, look at this. The program said, type an integer or a simplified fraction. I wrote the decimals, and the Pearson still gave me a correct answer. Said correct. 整数か、分数で書けとか言って書いたんですけど、小数で書いて丸をもらえてます。はい。Well, let's move on to the next one. Now, median. So now this one is basically a parabola. This is just a coefficient, right? And this is just a parabola. So we have some kind of parabola, and we are only looking at 0 through 21. And we need to find the place M that separate the area into 0.5 and 0.5, okay? So median is a place that when you integrate this from 0 through m, we want to get that equal to half of the entire area. 面積をね、2つに、ちょうどね、2つの合同な面積に分けるところを知りたいということね。So the integral of this one is, we already know it, it's here. So it's going to be 3087 times 1/4 times, we're going to plug in, oh, wait, no, I shouldn't do that. I wasn't doing integral of the same function. This is different function, sorry, because last time we multiplied by x, but this time you don't have to. So we have to integrate just a square function here. Okay, after integrating this, it's going to be 3087 1/3 x cubed, and you plug in 0 through m. So that's going to become 1 over 3087, 1 over 3, m cubed is equal to 1/2. Bring this number to the other side. So it's going to be m cubed is equal to half, 3, and 3087. And 3087 was this one. So this is going to be 3 times 9 times 7 cubed over 2. Okay. So m cubed is equal to 3 cubed, 7 cubed over 2. So to remove the cube, you want to take cubic root of this number. So that's going to be 21 over cube root of 2. Or if you rationalize the denominator, it's going to be 21 cube root of 4 over 2. I believe either one is okay. My answer here looks messy because I didn't simplify it. I just have 21 to the power of cube. Okay. So it should be the same number because 21 squared is 441. And if you multiply it by 21 again, it's going to be 441, 882. You want to get 9261. So this number can be simplified and should be simplified, but the Pearson accepts my answer. Yeah. Anyway, let's move on to the next question. Okay, number 8. Now we're going to have an exponentially decreasing probability density function problem. A manufacturer of light bulbs find that mean lifetime of a bulb is 1,200 hours. Assumes the life of a bulb is exponentially distributed. So this part, it said that assumes the life is exponentially distributed. So we are interested to use a function, this. It's 0 for negative x. And for positive x, you want to use c times e to the power of negative cx. This is exponentially decreasing probability density function. However, in the textbook, we found out the mean value for this function is turned out to be the reciprocal of the value c. So there is another version of this one, which is probably better, which is 1 over average e to the power of negative x over average for x greater than or equal to 0, and 0 for negative value of x. So this is the one we are going to use for word problems, especially when we are given some mean values. Okay, now for this one, so the function is because the average is 1,200, the probability density function we have to use is 1 over the average e to the power of negative x over average for x greater than 0. Okay, so this is a function we are going to use. Once you found out what you need to use, the problem is quite easy. Find the probability that the valve will last less than its guaranteed lifetime of 1,000 hours. So the model of this one is exponentially decreasing function starting with some value here. We need to find the probability that x is less than 1,000. That's what we want to find. Probability is area, so we just need to find. So we need to find the probability that x is between 0 and 1,000. Well, it said less than 1,000, so it should be like this, but it doesn't change the answer. And that is equal to integral of 0 through 1,000 of 1 over mu e to the power of negative x over mu dx. When you integrate this, it's going to be negative e negative x over mu. Okay. So you plug in 1,000 and 0 you want to get negative e to the negative 1000 over mu. Mu is in this case 1200. And plus e to the power of 0, so it's going to be 1. So in this case, it is 1 minus e to the power of negative 5 over 6. So that's the probability, and that's the area under the curve between 0 through 1000. Okay. And when you plug in this one into the calculator, it's going to be something like 0.57, I believe. Yeah. And I used the calculator to find this. Now, part B. In a batch of light bulbs, what is the expected time until the half the light bulbs in the batch fails? So we want to find basically a median. We need to find the median, okay? Because half of them is, the half-life, not half-life, the half of them will be turned off at the median, okay? So some of them is have a life around here, some of them life around here, some of them around here, and so on. And we need to find the median because median is the point where half of the bulbs are dead. So we want to find the line here such that the area here, left side of the line is 0.5. So this word problem is asking for a median. So the integral of 0 through the median of the function is equal to 1/2. Now integration of this one is same as this. And you plug in just this and this. So it's going to be similar. You're going to get this. Instead of 1000, you're going to get m. So it's going to be minus e to the minus m over 1200 plus 1 is equal to 1/2. Okay, so we just copying the result here. Yeah, integration of this one is here. Instead of m, we used 1000. Now we just plug in m instead. We are going to solve for m. So combine like terms. So 1 minus 1/2 is 1/2. And bring e to the other side, it's going to be like this. Use a log to rewrite this expression. So it's going to be ln of 1/2 is equal to the exponent part. Multiply both sides by negative 1200. We're going to get 1200 ln of 1/2 is equal to m. So this is going to be the median lifetime. We really don't like this negative here. So let's put this negative to here. So that looks slightly better. And that's going to become 1200 times ln of 2. ln of 2 is something often appears in chemistry, and that is about 0.693. Well, basically about 70%, 0.7. So if you know this is approximately 0.7, the answer is about 840. Just about 840, okay? So of course, there's some error here. So there's some round off errors here, but if you use a calculator, you can find it something close to 840. So exact answer is this. Rough approximation is this, but the more better approximation is here, 832. Okay, next problem, number 9. The mean waiting time to get served after walking into a bakery is 35 seconds. Assume that an exponential density function describes the waiting time. Complete part A through D below. So this one is once again, because the program said, oh, you can assume this, you can use the exponential decay function. So this is going to be 1 over mu e to the power of minus x over mu for x greater than 0. So we are going to use the same model for this program. The program says the average. So the average value is the mu is equal to 35 seconds. So that's what we are going to use for this question. Okay. So in this program, we have a specific value for mu. So we are just going to use this function for x greater than or equal to 0. Okay. Now let's answer the problems. Part A. What is the probability a customer waits 15 seconds or less? Remember that this model looks like this. And the average is 35. We need to find the probability that the customer waits for 15 seconds or less. So 15 or less. So the probability that the random variable x is below 15 is equal to integral of negative infinity through 15 of the function. But from negative infinity to 0 is just 0. So we can ignore that part. So this is basically 0 through 15 of the function. We are going to integrate. After the integral, it's going to be negative e to the negative x over 35. And you plug in 0 through 15. And plug in 15, you're going to get negative 3 over 7. And plug in 0, you're going to get negative 1. And you're going to subtract that. So it is 1 minus e to the minus 3 over 7. Okay. And this 0.349 is basically the value about that. Okay. It's just about that. Okay. Next problem. What is the probability a customer waits longer than 2 minutes? 2 minutes. 2 minutes. Be careful about the units. This model, we are using a seconds. We are using a seconds. So 2 minutes must be rewritten as 120 seconds. So we want to find the probability of the random variable, the customer's waiting time to be greater than 120 seconds. So now we are looking at this region, 120 or larger. Okay, so the problem is to find the area between 120 through infinity of the same function. Okay. Now, we have to use the b, but the integration is the same. So after the integral, you're gonna get this antiderivative, and you plug in b and 120. And as you may guess, as b goes to infinity, it's gonna be disappearing anyway. Okay. And we make b goes to infinity. Now, as b goes to infinity, this part becomes e to the negative infinity, which is basically 0. So the answer will be just e to this part, which is e to the 724. Okay, so that's the probability the customer has to wait for more than 2 minutes. Part C. What is the probability a customer waits exactly 5 minutes? Okay, which is same thing as probability that x is equal to 300 seconds, which is same thing as probability that x is between 300, and 300. Which means you have to take an integral from 300 to 300 of the function, and that is equal to 0. Okay. It's basically talking about the area for x is between 300 and 300, which has no width. Yeah, no width here. So the area is equal to 0. So there's no chance that the customer wait for exactly 5 minutes. Part D. If 200 customers come to a bakery in a day, how many are likely to be served within 3 minutes? Within 3 minutes. So that's what we are going to do. So within 3 minutes means within 180 seconds. So first of all, we are going to find the probability that x is below 180 seconds, which is you want to take an integral of 0 through 180 of the same function. Okay, same function. So that's something we have already did it many times. So instead of 15 here, you just plug in 180 there. So kind of getting boring at this point. So it's going to be 1 minus e to the negative 36 over 7. Okay, so that's the probability. That's the probability. Now there are 200 customers coming. So we need to multiply the probability by 200 to make it the number of people. Okay, number of people. By the way, this is roughly e to the negative 5, and that number is very, very small. So the answer should be very close to like 99% and multiplied by 200. So it's very close to 200. And in fact, the answer is, the approximation is after using calculator, it's going to be 199 customers. It's going to be served within 3 minutes. Okay, let's move on to number 10. Number 10, 11, and 12 are problems related to the normal distribution. Normal distribution. It's called the 正規分布. So the normal distribution have a probability density function looks like this, where the peak happens at the median, not the median, mean, or the expected value. Okay. And of course, the area under the curve is equal to 1. And so this is some special probability density function and have a name, the Gaussian distribution or normal distribution. Okay, the function has a formula looks like this. So this function has an expression looks like this. 1 over square root of 2 pi times sigma times e to the power of negative x minus mu square over 2 sigma square for the x between negative infinity through positive infinity. So this is the model we are going to use in the next 3 problems. Okay, looks very complicated, but the mu and the sigma is a parameter given in the programs. The mu is the average or mean. Mu is the mean. Okay, and the sigma is a standard deviation. And I'm going to show how we're just going to apply it. So problem number 10, the assembly time in minutes for a component at an electronic manufacturing plant is normally distributed. Here, normally distributed. So this keyword suggests us to use this formula, okay? to use this function, we want to know mean and the standard deviation. And in this case, with a mean of 54, and the sigma is equal to 5. Okay. What is the probability that the component will be made in less than 1 hour? Be careful about the units here. This 54 means in minute, time in minute. So this model is using the minute for the time. So less than 1 hour means less than 60 minutes. Okay, so the function we are going to have is 1 over square root of 2 pi times sigma, which is 5. E to the power of negative x minus the mean square divided by 2 times sigma square. So we just plug into this. Okay. We want to find the probability. We want to find the probability that the random variable takes a value less than 60 minutes. So we want to find the area left side of 60. So we are going to integrate from negative infinity through 60 of this function. Okay. Now, let's use a calculator. And the reason for using a calculator was to justify myself using calculator is because the program said here, T. This means we need a technology. We will use the technology to find the answer. This function is a very known function, and we know that this cannot be integrated by hand. So we cannot integrate this one actually. So we need to use a calculator. So I'm gonna show you the calculator. Can you see it now? So this is a function that I put it. This is a function, and we are going to integrate it for interval of a through b. Now, s is a standard deviation. So in this case, standard deviation is 5. The mean is 54. And a is negative infinity. Okay. And b is 60 minutes. Okay. I guess negative infinity is not recognized this one. So I'm going to put some big number, big negative number. Okay. So that's going to give us a value of 0.88493 something. So this is the area between negative 1000 through positive 60. The area under the curve, this blue part, that's going to be the probability that x is less than 60. So answer is 0.8849. Let's make this is to 2000. Does it going to change any values? So it does change slightly in this part, but basically 0.8849 seems to be the correct value for this program. So let's go back to the program. So you just type in the function and you type in the range of the integral, and the answer rounded to 4 decimal places. So it's going to be 0.8849. Okay. So you just write down this and use a calculator to find it's going to be 0.8849. Okay, next problem. The average height of American females aged 18 through 24 is normally distributed. So here's a keyword, normally distributed. That means we can use this model for this problem as well. Now, the mean in this problem is 64.7. Okay, so number 11. And the mean is, this is normally distributed. Normally distributed. So we can use this formula. Again. まあ何回か書いて覚えましょう。はい。And with mean is equal to 64.7 inches. And the standard deviation is 2.9 inches. Okay. Part A. What percentage of females are taller than 66? So we are kind of writing down like this. So here the middle is 64.7. So what is the probability the randomly picked female taller than 66? So we want to find the area here, right side of 66. So we are setting up the integral for 66 through infinity of 1 over square root of 2 pi times sigma e to the power of whatever here, whatever, okay? Then you will use a calculator to find it. Okay, so let me show you the calculator once again. So that's gonna be, now the standard deviation is 2.9 and average is changed to 64.7 and the lower limit, lower value is 66 and we are going to integrate it to infinity, but infinity seems doesn't take in this GeoGebra, so I'm going to just put some large number, 100, 1000. So the answer is 32.69%, 32.3269, 3269, 326977, 326977. So the answer is, because it is in percentage, you multiply it by 100, so it's going to be 33%. Second problem is basically same. It said, what is the probability that the female is between 5 and 1, 5 feet, 1 inch, which is same thing as, 5 feet, 1 inch is same thing as 5 times 12 plus 1 inch. We need to change to inch because we are working with inch in this model. So in this case, what is the probability the female's height is between 61 inch through 64 inches? So everything else is the same except, so this function is same, but the range of the integral is changed from 61 through 64. So what we are finding is we want to find the area between 61 and 64. Okay, so that's all we need to change, and the answer is the probability. The program said percentage here, but this one said probability, and it is 0.3036 after using a calculator. So let me show you by the calculator. So everything setting is same, but lower is 61 and higher is 60. Okay, and you get 30.36%. Okay, and you see the area here. You see the area here. Okay, you see the area here. So that's what we just found. Okay, last problem, number 12. It's going to be about the same thing. So a diastolic blood pressure in adults is normally distributed. So we are going to use the same model for this problem, which is this. Okay, with the mu is equal to 70 millimeter of Hg, and sigma is equal to 13 in a certain population. In a random sample of 400 adults from that population, how many would be expected to have a diastolic blood pressure below 80? Below 80. So although this cannot be negative value, but for model-wise, the blood pressure could be any number, any real number. Yeah. Anyway, Like, so the median is, mean is 70. And we want to find the probability that randomly picked value is 80 or below. We want to find this area. ちょっと反応が。So we want to find this area. So we are going to find the area from negative infinity through 80 of this function. Okay, so we need to find the probability. We want to find the probability for the random variable x to be less than 80. So that's going to be negative infinity through 80. Okay. So this is what we want to find. The model we are going to use is this, with sigma is 13, and the mean is 70, and sigma is 13. And again, we cannot integrate this one by hand, so we just use a calculator. Okay, so if we use a calculator to find the probability, let's use a calculator. Yeah, I'm just using the same GeoGebra right now, so no need to see it really. So S is 13, and the mu is 70. And A is negative infinity, which I just put negative 1000. And the B is 80. And what I get is 77.9%. So this is equal to 0.7791 something. Okay, so that's a probability. That's a probability. But there are 400 people. The program is asking for number of people out of 400 who satisfy this condition. So we need to know the number of people. So we multiply it by entire population multiplied by the probability. So that's gonna be 4, 6, 3, 1, 3, 1, 3, 311.64. That's approximated number of people satisfying this condition. So using to find the nearest whole number, so it's gonna be 312 people. Then out of 400, have a blood pressure below 80 meter of Hg. Now I'm gonna show you how to work with a normal distribution using a spreadsheet. It's maybe too small. Sorry, it's not. Okay, so maybe I should show the program. Wait, where is it? Yeah. So we can find the probability, area under the normal distribution curve using a Excel spreadsheet using a norm dist. You see norms dist. Then you see you can find, you have several inputs to do. The input value is it's actually counting from negative infinity to something. Okay, so in this norm dist function, the input is b value. A is automatically negative infinity. Okay, the b value, the integral upper value is x. And the mu is, the mean is basically you have to plug in its mean, and the standard deviation is a standard deviation you want to input. So when you use this function, you have these three inputs, and it's asking for cumulative, and you're going to choose yes for this part. Okay. So for this problem, the integration is from negative infinity to 80. And the standard deviation, mean is 70. And the standard deviation is 13. So and we're going to choose yes here. Okay, so let's look at it. So norm dist, norm dist. So x is 80, mean value is 70, and the standard deviation is 13, and the cumulative is yes. Maybe yes と言え。yes っていうふうにちょっと言っちゃいけないな。yes は true にしなきゃいけないかな。まあ、true is same thing as 1. Yeah. Okay, so that's going to give us 77.91%, which we found it already, right? And when we multiply this value by 400 people, we got 312 people. So this also works. So if you go back to the previous one, well, how about if the problem is not from negative infinity? Does it work? Let's wait. So let's do the problem number 10. So problem 10 is x is negative infinity to 60, negative infinity to 60, so negative infinity to 60, and the average is 54, and the standard deviation is 5. So the answer is 88.49, which is same. Quick, it's kind of quick, right? Yeah, so if it is from negative infinity to 60, the norm distribution function works. If you need to find different one, like 66 to infinity, then you can do like this. So let me show you. Let me show you this. Remember, the probability density function has a total area of 1. So if the question is asking for this part, the spreadsheet only calculating from negative infinity to somewhere, negative infinity to x. That's what the calculator does. Okay, so use the calculator to find negative infinity to 66, and you subtract that number from the entire. So 66 through infinity of this part is equal to 1 minus negative infinity to 66. That's the idea we are going to use. Okay, everything is 1. So you're gonna find the green part using the calculator, and you subtract that number from 1 to get the blue area. So let me show you that one. Where is it? Okay. So I think you can see it now, I believe. Okay. So first of all, let's find negative infinity to 66. The mean value in this case is 64.7, and the standard deviation is 2.9. So that's going to give us 67%. Now you are going to do 1 minus the value here to find opposite area, the blue area, and which is 33%. Okay. And if you want to find 61 through 64, that's kind of harder. That's kind of harder. But what we are going to do is we're going to do the same thing. We're going to do the same thing. So in negative infinity to 64, and you do negative infinity to 61, and you're going to take a difference. Okay, so now you want to take a difference. D13 minus DE13. That's going to be the answer to this problem, 0.3036. What's this mean? Negative infinity to 64 minus negative infinity to 61. The difference is going to be area between 61 through 64. So that's how we can use a spreadsheet to compute the normal distributions. That's complete explanation for today. Thank you for listening.